In this video, we're resurrecting an enterprise cache from 2001, the CacheFlow SA-725. Once we get through some hardware failures, I want to put it to the test, so we'll literally blow the dust off an old Pentium 3 Compaq DL-380 and get a 24-year-old copy of Apache web server installed on it. I'm going to attempt to recreate a load test that Network World did back in 2001 against this CacheFlow unit, a part of which is running a denial of service attack called Jolt2 against it. We'll compile and run the Jolt2 attack using a cool old Dell laptop running an interesting Linux distro. This video is a whirlwind of early 2000s enterprise hardware, networking, and software. Let's get into it. Today we're going to have a look at this CacheFlow SA-725. This is a 1U appliance, quite large, and I suspect it's going to be very loud. It's sort of counterintuitive, but these 1U machines are actually quite a bit louder than a taller, bigger server because these smaller fans have to spin faster to move the same amount of air. As the name of the company implies, this is a cache, specifically a SA-725 or Server Accelerator 725 from their Series 700 line of units. I bought this in a large lot with a ton of other interesting stuff from Winman 486. If you want an overview of all that stuff before I have time to get them into full videos, that's over on my Patreon. Ever since I picked this thing up, I can't stop thinking about it. Look at this joystick. Does that remind you of anything? CacheFlow put a damn N64 joystick on the front control panel. I mean, just look at that. Think I could play N64 on this bad boy? Just kidding. This thing came out in 2001, and you might be wondering, well, what is a cache in the first place? Well, if you're hosting, let's say, a website and it's got assets, images, HTML, CSS, text, whatever else, JavaScript, there's a server somewhere providing that to the web requests. For example, we might have this Compaq ProLiant Pentium 3 machine acting as the actual web server, so it's hosting something like Apache or web serving software, and it needs to persist all those files on slow disks over here. So every request coming in is going to hit the disk, and eventually you're going to hit a point where it's either too slow or it's being overwhelmed or both. What you do is you put something called a cache in front of it. So as requests are coming in, this thing grabs it from the server if it's never seen it before. But if it has seen it, it's just going to return it right away. This thing never even knows that someone's asking for it, and it doesn't have to do as much work. Plus, this is probably going to store that stuff on really fast media, very likely on RAM. These guys, But the problem with these is that A, they're expensive. You can't load up all your servers with these. And B, when the power goes out, everything on these is lost. So you still need slower media to permanently persist your website. You don't want to just lose everything when you turn the machine off, but you need a cache in front. If your scale is such, you don't always need a cache, so that you're not pounding your web server disks and CPU, and you just let this thing return stuff quickly. I hadn't actually heard of CacheFlow, but they actually started in 1996 and had the classic .com bubble ride. Mark Andreessen invested $3.1 million in 1999. And then, of course, the valuation of the company had tanked 97% by early 2001. But they were actually around in their final form, named Blue Coat, all the way up to 2016. Theoretically, this thing is hosting a proprietary OS, and they claim it does all sorts of smart stuff about deciding when and how often it should fetch from the server dynamically based on the usage profile of whatever you're grabbing, like an HTML website or something. And I find that pretty interesting because in programming, they say the two hardest things are naming things and cache invalidation. So I find that pretty suspicious and also intriguing. Cache invalidation is the cache deciding it needs to go back to the root source, our disks in this example. So for example, you have like a HTML website, clab.html. Invalidation is the act of telling this thing, hey, you need to go get the fresh stuff. And that's a hard problem to solve, and not really in my HTML example, but generally speaking in software. And this thing, it claims to be set it and forget it. You point it at your web server and this thing just does the rest. I don't even know if this thing works, but the game plan here, and I think I'm going to regret saying this, is trying to faithfully recreate a load test that Network World, the magazine, did on this machine back in 2001. They used the Apache web server. They didn't say where they hosted it, so I think this Compaq ProLiant Pentium 3 machine will be relatively era appropriate as our host. Before we power it up, I want to open it up. I think it just has a few of these security bits around the perimeter, which won't be a big deal for us. I have to imagine this thing is just going to be absolutely packed with RAM to act as a reasonable cache. So I'm very curious to see what's inside here. I don't know why they would have used such a massive chassis. So it's probably got to have some pretty hefty horsepower in terms of CPU as well. There's one on either side like I just took out, and then there's just several across the back here. So let's get in here. The very first enterprise server I ever bought from RePC back in like 2003 or something was some black 1U no-name thing like this. So maybe that's what drew me towards it. Here we go. There is a whopping 1 gig of RAM in this thing and 2 hard drives, probably in a RAID or something for speed. Not entirely what I was expecting. That's weird. Oh, and a Dallas time clock chip. I'm sure that's in great shape. Yeah, it's got 2 Seagate Cheetah SCSI drives. These must be rated for speed. It's not immediately obvious to me how large they are, but that doesn't really matter. It's very clean and well laid out, I'll give them that, but this is not what I would have expected. I would have thought you'd have the proprietary OS on some ROM. It loads into like RAM disk. And I expected this thing just to be blasted with RAM. I mean, that's how you would do it these days, I think. There's some sort of daughter boarding here going on. Not sure what that's about. I'll pull that CPU, get a look at what we're dealing with. In the corner here is the SCSI controller, which is actually on an edge connector to the main board. And these go off to the hard drives. It's an LSI Logic Symbios host adapter, apparently. Flipping around again, the RAM is 512 megabyte PC100. Not much to write home about. And then the CPU over here is some sort of Socket 7 CPU. It's always funny the games they have to play to get everything into a 1U chassis. Look how low profile everything needs to be. These hard drives barely fit. There isn't actually anything holding down this fan assembly to the CPU other than the thermal paste, I guess. So I'm just going to leave it for now. Socket 7's either going to be a Pentium or like an AMD K6 or 5 or 7 maybe. Nothing with a lot of horsepower, that's for sure. So this must not be too CPU intensive, or I'm just stuck in 2024 and I forget how simple it could be in 2001. The data sheet said these are 2 18 gig SCSI drives, and it says that it can handle a working set of data at 1 gig, which is the RAM. Not much left to do but fire her up. So I got her on the serial port here. It's almost certainly 9600 baud. And I'll point you at the screen, flipping on the power. Yeah, relatively loud. Not too bad though. Those were nice fans in there. Nothing on the serial port. A lot of activity on the disk indicator. I think that's good. This isn't looking good. Oop. A little more disk. Oh, look at that. System busy, please wait, once I played with the joystick. So I'll leave it for a while, let it do its thing. It's dead. I can't get it to do anything other than show that system busy, please wait on the front. Nothing out of the serial console. The problem with something like this is it's entirely proprietary. There's not a place to hook up a monitor or anything to this thing. It runs an OS, and I found one article that mentions that these are redundant. You can also configure it to like switch between one or the other. We could have a disk issue. I hear them spin up. They sound okay. One of them kind of makes a little bit more noise than I'd like while it's spinning down, which might very well could be our issue. Could be RAM. So I'm going to play around. I'll swap the RAM and stuff first and figure that out. See if I get any life out of it. It's very odd. If I swap the RAM around, I no longer get any disk activity, and I can't even get it to show this message anymore. So I swap the RAM back, and it's like trying again. So I have this indicator here, and then down in here, you'll see a reflection, hopefully. The disk activity indicators are going there. And then there's another one on the SCSI controller itself. I hear the disks doing stuff. Maybe I should just leave it. I'll just leave it like this for a few minutes. Could it be RAM? I suppose that's possible. I was thinking for sure it's the disks. They're trying. Oh man, something's happening. Holy crap. I think both of them are okay. I switched to a null modem. I had done this before off camera. In the previous shots, you probably didn't see it because I'd been playing around with having a null modem and not on my serial cable. And we're getting somewhere. It's trying to boot. Oh man. There is a chance. Yeah, I wonder why I couldn't get anything before.
I tried this exact setup. Seconds remaining. Okay, it's having trouble booting from whatever this is, so they are just for redundancy. I'm going to tell it to boot from the other disk. Man, we might have to image these disks like ASAP. Let's see if we can boot from the other disk. Yeah, I probably need to figure out a good way to image those disks, because I'm sure as hell not going to find this software again. No! It's just doing the same thing. That didn't work. I'm going to mess around a little bit. No matter which disk I choose, it just sort of loops, but we are sort of getting somewhere, which is exciting. Yeah, this is where it gets stuck, searching for device. I've tried several times, so it sees both drives, I think, is what I'm looking at, and it thinks it's got two different bootable systems, both last booted, it claims, in 2002. Who knows how good its clock persistence is, though quite possible, because it has a different date for each one. The default is this slightly newer release of the software, and the old one is this one. Neither one can boot, so I'm going to try to tell it to boot from the older version. I'll show you what it does. It tries. After a few moments, it just loops. I think the whole thing restarts. It's having trouble. I don't know if there's like any diagnostics I can get into. You know, all the regular suspects do nothing.
I'm thinking through this a little more. It's very bizarre that when I swapped the RAM, I got no disk activity. Also, I kept saying it saw both disks, but it only actually saw one. But these could be rated, so they might be presenting themselves as one disk, even though there's two physically. And whatever basic BIOS type logic is going on here is smart enough to see that across the two disks, there's two versions or something. I really don't know how this setup works. Long story short, I'm going to try to scrounge up some known good RAM before we deal with imaging these disks. All these computers I've got floating around that would have PC100 RAM don't have any in them, so that's too bad. That Compaq actually has PC100 RAM, I think, but it's going to be ECC RAM. Server error code correcting server RAM, so it's not going to work in this CacheFlow unit. Been looking everywhere down here, and I think the only thing I have that has PC100 RAM in it are these Cisco PIX firewalls. So I'm going to open one up and see. Sure enough, a whopping 64K of it. Let me open up another one. Yeah, they all just have abysmal amounts. I don't even know if it's worth experimenting on that. I'm finding it very comical that what's slowing me down on this experiment is I don't have any of this incredibly cheap PC100 RAM. We're just going to stick 2 out and see how we fare. The tolerance is so tight right here that this thing actually doesn't open all the way. It hits the hard drive assembly. You can just barely get it out. This poor CPU gets very hot, so I am placing the lid back on for airflow reasons whenever I'm running the machine.
It's moving along like before. I'll just let it boot the default version, number 2, the newer one. You can hear the disk spinning when it's at this stage. We've never seen the serial number show up. Could it just be a bad RAM stick? It is. I saw this in the manual. Wow. Enter 3 times. It was a bad RAM stick. Oh man, I'm getting on eBay right now. Let's take a look. Command line interface. Wow. Enable. Number on the back, it said password 1. In my previous video, I'm talking about Cisco-esque command lines, and this is yet another one of them. What? The disks are fine. Let's get a computer on the network and take a look at this web interface. Start with the basics. Let's see if I can ping it. I can. Theoretically, we can hit port 8081. Ooh, yeah. Look at this. Oh, man. Management. Oh, boy. Yes. I don't know this password. We might have to configure this from the CLI. It's a big old Java app from what I was reading. Look at this.
Well, that's like absolutely massive. This thing is working great. I'm going to hunt down another one of these 512 sticks so we can get the full total of 1 gig in here for our test. That's going to take a few days for these to show up, at least, I'm sure. I'll probably just buy a bunch of them on eBay. I'll find a lot. Let's get our other components set up. We need a server, and we need that Dell laptop to run the Jolt 2 denial of service from. Plenty of work to do in the meantime. Network World reviewed this SA-725 in April of 2001, and as part of that review, some testers from the Network World Global Test Alliance ran load tests against it. They describe their tests in a column on the right side of the article, and they provide both a ton of information while also leaving some critical pieces out. They used Apache 1.3.12, as was the style at the time, as the web server software. That won't be hard for me to find. But they don't say what hardware they were using for the server. The load test tool they used was Mercury Interactive Load Runner, which is actually still a commercial product today. It has changed hands several times over the years, though. I don't feel like dealing with hunting down a 23-year-old version of that, so we'll use Apache Bench for our test. They outlined two basic tests that they ran: 5 concurrent users hitting the Apache web server directly, and another one with 5 concurrent users hitting the CacheFlow instead. For both tests, they measured CPU utilization on the web server, requests per second processed, and request latency. For some reason, they don't mention how many requests they generated in total, so I'll have to fill in those details myself. They also say they ran a Jolt 2 denial of service attack against the CacheFlow in an attempt to, quote, break the box. They felt it was important enough to note that they ran that Jolt 2 test from a Dell Laptop running Red Hat Linux 6.2. If you don't know what a Jolt 2 denial of service attack is, well, I forgive you because I had no idea until I read this article. Basically, it's a very small amount of C code that can be compiled and ran against a web server that's accepting requests, and long story short, it'll spike the CPU to 100%. Bringing all that together, here is our load test arsenal. I've got this modern ThinkCenter computer here. We'll run Apache Bench from that to generate load. The big guy here, this Compaq DL-380, is a single Pentium 3 machine. We'll use this as our web server. In fact, I bought this in the same lot from Winman as I got the CacheFlow. I don't know if this one works. I actually have another one that is loaded out with the dual Pentium 3s, but it's running Windows NT. I use it for other stuff. In this video, we'll find out if this one works and get it cleaned up, and probably get Red Hat or something installed on it. And finally, we have our very own Dell laptop. I'll try to scrounge up an example of the Jolt 2 source code, and then we'll compile it and run it from here against the CacheFlow. While we're waiting for this RAM, this is actually going to be a ton of work. The Compaqs are kind of hard to set up, as you'll see. We'll start with this Dell and see if we can compile that Jolt 2 attack. A while ago, the folks over at Free Geek Twin Cities gave me a real good deal on a pile of stuff, including this Dell laptop. And by good deal, I mean basically shipping. They hooked it up. So huge thanks to them, especially Y2KMan2K from the Serial Port Discord, who arranged the whole operation. Today we're going to try to put this Latitude D610 to work. This will not be the last time you see this laptop on the channel, because they also sent me this massive dock that goes with it, which on the back has a very suspicious cover. And inside there is a full-blown PCI slot in the dock. So using this dock, you can just like put a PCI card in and the computer will have access to it over the PCI bus. Absolutely wild. So yeah, we'll be messing with this in the future. In the meantime, the folks over at Free Geek were kind enough to load this up with my favorite operating system. That's right. She's running the Hannah Montana Linux distribution. Should we attempt to compile and run the Jolt 2 denial of service attack from the Hannah Montana Linux machine? Yes. The answer is obviously yes. Don't mind me, just looking for the Jolt 2 denial of service source code on my Hannah Montana themed Conqueror browser. Okay. Got what's hopefully the source code. Gotta remember how to do this. This is pretty much what the network world folks were probably doing, you know? Alright, on come the errors. Just warnings? Oh, we're in, dude. Oops. Oh, dude, we're so in. Well, now I need something to run it against. Things have escalated. We're gonna try to blow this thing up. Got both of these on the same network, using this little guy, naturally. Also been trying to up my game with the VGA capture. So I got this OSSC I've been playing around with, and it's pretty crispy. And the noise you're seeing is just a crappy VGA cable. I don't think it's a problem with the setup. I'm still struggling to figure out how to screen capture it well though, so baby steps. At any rate, it sounds like the Jolt 2 only affects Windows servers, or at least that's what people are saying. So maybe we got to install Windows on that Compaq when we're done with this. Not sure. I also have no idea if Windows XP is even vulnerable to this, but we're going to give it a shot. Like I was saying, they're on the same network. They can ping each other. This one is 10.0.0.3. This one is 10.0.0.2. I'm going to try to run the Jolt executable against the Windows XP machine. I have no idea if a server needs to be running on this Windows XP machine or what, but I'm going to kick it off right now. Ah, yes. The pain begins. Good news, it works if you run it with sudo. Let's watch the chart on the XP machine. I'm going to try kicking off that executable right now. Yeah, look at that. So it's not pegging 100%, but you can see the line right when I started it. It's definitely keeping it busy. This is a Pentium 4 machine, so that would have been a lot more powerful than whatever was going on in 2001, and that CacheFlow has like a Pentium or something, or some equivalent. Yeah, look at that. It's keeping it real busy. Something like 40, 43%. That's fascinating. Let's see what happens when I turn it off. Yeah, drops right back down. Okay, I would say this machine is either powerful enough or not as susceptible to this attack, but we'll get some older software on that Compaq, and I bet we can peg the CPU. This is really interesting. This is so cool. I'm just playing around with starting it and stopping it. Fascinating. Honestly, I thought this would be the hardest part of the setup, and I was fully ready to give up and just do a normal load test. But we do appear to have a valid Jolt 2 executable, and at least keeps this Windows XP machine busier than it ought to be. So that's exciting. We're done with this. Well, let's move on to the Compaq. This will be our web server, a Compaq ProLiant DL-380. This is a Gen 1. HP bought Compaq a couple years later, and they still make these DL-380s. They're on Gen 11 or something. I think these are very, very cool looking machines. Very iconic, classic Compaq styling. This one has suffered some sort of traumatic physical event. It's very hard. It's very hard to get the case to go on right. It's definitely been like bent or warped or something. This is loose. I'll show you what's going on with that when we get inside. So let's open it up. These are very well built machines, but the biggest thing you have to worry about is underneath this air baffle. The RAM and CPU are in here. Compaq used this like horrendous foam. Like, it's just disintegrating. It's gotten so old. The other unit I have, the foam is manageable, but it's just gotten everywhere in here. All this dust and stuff, that's just foam that has disintegrated. This one's got one Pentium 3. It does have a slot for another one if I hunt one down along with the voltage regulator. Back towards the front, there's some sort of misalignment with the tray. Watch that as I close it. This board in the back flexes. See that? It's not lining up quite right, so that's concerning. We'll have to see what's going on with that. But first, I think it's time to blow this thing off with the air compressor. I think that's going to get us in really good shape. Shouldn't be too bad. As I'm glancing at this, definitely some different configuration from the one I have. Some sort of SCSI terminator. This is like SCSI 2, that connector. I think my other one just had some SCSI 3 stuff going on. The CD-ROM drive is unhooked for some reason. I'm glad I noticed that. That would have drove me crazy. It's got IDE, but it doesn't have a disk controller. So you can't actually use IDE hard drives or CF flash cart, converters in here. It's SCSI only unless you put a PCI card in. But enough of that. I'm going to get this over to the garage and we'll blow it off. That is much, much better. I'm sure it'll still smell when it fires up, but that's okay. I kept the baffle screen itself, I guess, just because, but yeah, the foam is entirely off of it. I think it's okay. I never run these things around the clock. It's got a fan right here blowing air past the Pentium 3. In fact, let's pull that out and take a look at it. I don't know why, but I find it really interesting that these things have Pentium 3s inside. In my head, Pentium 3 is not a server processor, but I mean, of course it was. It was a good processor back in its day. Here she is. I'll have to hunt down another one to get this one doubled up. That'd be pretty cool to have two of these with two Pentium 3s. The only other thing of note about this particular unit is it's got a dual NIC in it for whatever reason. I'll just leave that there. I'll attempt to keep this real simple. We're just going to put one 36.4 gig SCSI drive, Compaq branded SCSI drive, of course, in the top bay here. And like I was showing you before, it was sort of flexing that board, so let's see if we have better luck. This is a different tray, and it has a drive inside. That seems fine. Okay, that's good. Got the lid to more or less shut the way it's supposed to. I was talking about maybe we needed to put Windows on here, but Apache 1.3 definitely wasn't made for Windows. I think Apache 2 is when that started to become a thing. So the testers at Network World would have been using Linux. We'll just use that Red Hat Linux 6.2 they mentioned for the Dell laptop. We'll try to put that on here. Now these are very odd machines. When you boot them up, you can't get into the BIOS unless you have one of these, a Smart Start CD and or there's a floppy disk version. I'm hoping I don't even need to mess with that, and I'm just gonna boot to my Linux CD. Hopefully we'll be able to detect the drive and just install it, and I don't even need to get in the BIOS. But if I do, I'll bring you along. First things first though, we'll get her hooked up to the bench monitor here and fire it up, see if it's okay. Check out this Compaq mouse. I'm gonna give it power right now. We hear the PSU spinning. That's what we want. And I'm gonna power it up. They're quite loud, I think. Ooh. That's empty. That's good. I have to clean that off. Pretty dusty in there. It has a VGA out, which is pretty nice. I want to say it takes a while for it to actually display something. We'll see. There she is. Okay. So far, so good. Pentium 3 800 megahertz. It knows that one of the power supplies is not plugged in. That's no big deal. It's got an internal SCSI controller that it's initializing. I can hear it spin the disk. That's also probably good news. It had a RAID array set up before, and it's just complaining that, hey, I don't understand what's going on with my drives here. It says pressing F1 will erase non-array data. Okay, let's do that. And look at that, it says run the Compaq array configuration utility. That's what I was talking about. So check this out, you can't just get into a normal BIOS. I guess let's try F10 for partition utilities. Yeah, it's just confused, and now I gotta restart. I do really like these machines. They're built like absolute tanks. Okay, let's try pressing F1 this time. And I don't think anything happens. Banyan Vines. Wow. I would like to install minimum settings. I've never seen this before. And it's off the screen. 1 second. Just gonna auto adjust here, maybe. Yeah. Minimum settings, generic DOS. Sure, 1. Anyway, these things kind of like to be configured to know they're running Windows or Unix or whatever, and they kind of persist that in the BIOS for whatever reason. At any rate, I'm going to start burning some Linux disks, and hopefully we can just avoid all the Compaq funny business and get that installed on here. I am going to need to run the configuration utility because it's presenting 0 logical drives, so I need to get that smart array controller configured even though I only have 1 drive. I used this version 5.5 last time, so hopefully we have luck this time. This disk drive is having trouble. I'm a little suspicious of it, so I might have to steal one from my other machine. Yeah, it is struggling. Never mind, there is a way to build the array from a ROM. I didn't even need to load any additional software. It's on the machine. We're doing a RAID 0 because we have 1 drive. 1 logical devices. That was easy. I'm very suspicious of this disk drive, so it's trying to boot from it, I think, and struggling. New plan, I'm writing a bootable floppy disk, which came on the Red Hat Media. And it's so funny, like, I like to watch like heavy equipment type channels like Diesel Creek and Andrew Camarada, and they buy like a big old machine, and then they need like another one to help fix that first one when it breaks down, and so on and so on, and they just need like more and more stuff to work on the original stuff. I just bought this grease weasel. Like last week I learned how to use it, and I'm writing a boot floppy disk image with it, which I just wouldn't have been able to do easily before. Anyway, there's some sort of analogy in there when it comes to retro computing. You buy one thing and then you need another piece of equipment to fix the first thing. You know what I mean? It didn't work. I'm getting nowhere fast. I'm gonna swap the CD-ROM. Kind of looks like you have to take like everything apart to get that drive out, and I don't want to do that. So we're gonna go into expert mode here. Get this other drive in here just floating around. Oh, ho, ho, it was the CD-ROM. The old Plex writer saves the day again. What a workhorse. It's missing its button, so you have to use like a implement of some sort to... Anyway, this is how computing should look anyway. I'm going to get it installed, and if anything interesting happens, I'll be back. That was not straightforward, but check it out. Red Hat Linux 6.2 on the Compaq DL-380. Let me give you the cliff notes of what I just went through.
I got into the Red Hat installer, and then while it was formatting the disk, it just froze. And then I could never detect the disk again, so I had to pull this one out and replace it with a different one. The Compaq was just acting funny, wouldn't persist settings, so I decided to pull the CMOS battery, reseated the RAM after blasting it with a bunch of contact cleaner, and it really wasn't making a difference. I was using the Smart Start version 5.5 that I had luck with in the past on my other Compaq, and it wasn't able to boot into Smart Start, and it was acting really weird. So I unpackaged the complete version I've got of 4.9. If this is not on the archive, I will put it up there. Got that in there. It's got yet another splash screen. And finally, I was able to coax it into booting into the array formatting tool. This Smart Start stuff is pretty interesting. It's clearly just some sort of weird embedded version of Windows 95 running. Changing the battery, setting up the array, getting all the settings persisted must have helped because I was finally able to install Red Hat. I was finally able to mount an SMB share, an ancient one on my TrueNAS. And now we just built Apache, and now I'm going to install it, hopefully. I'm embarrassed to say it took me well over an hour to get here. It has ancient versions of NFS, so my NFS shares didn't work. I was finally able to mount an SMB share, get Apache over there. Building it and installing it was no big deal. And here it is, the default Apache homepage running on that Pentium 3 machine. Setting up Apache back in the day was like a rite of passage. This is such a sight for sore eyes. I am going to keep forging ahead here. I'm making progress, I promise.
Look what showed up. Our replacement RAM. Now I actually have to learn how to use this thing, and we actually need to get a pretty sophisticated network going. We need to get two basic networks going. One that's everything before the cache, so like public traffic coming in, and then everything after it, where this machine will be hooked up, and some of this stuff needs to be on both. This is my load tester. I want to generate traffic against the cache and against the web server for testing. I want to get this on both networks. It's got a NIC on the back, of course, and I'll give it a second one with this little USB to Ethernet adapter. Miley Cyrus needs to be on the network before the cache, and then my machine that I'm going to control all this with and screen record and everything needs to be on one or the other, at least this one. Makes perfect sense, right? To accomplish all this, we'll use these Nortel Networks Business Policy Switch 2000s from a previous video. You can tell this is like a really serious operation because it has business in the name. I'm going to get this RAM installed, do a little research, wire all this up in my room with the server rack so I don't have to listen to it for obvious reasons, and then I'll be back and hopefully we'll do some load testing. Hi, it's me from 3 hours later. I've got a nice stack of stuff building up. The RAM in the CacheFlow is working just fine. It's fully functional. I was very wrong and confused about how you network this thing up. I was talking about multiple networks and it flows into one and then talks to the server on the other. I kind of just like thought that's how it might work. Wrong. I was digging around in the CLI and trying to figure out like where you pointed at the web server, and I was getting nowhere. Finally, I started looking at the documentation that came with the web interface, and they mentioned something called transparency. And I finally understood how they want you to make this thing work. They sort of casually mention that you should configure your network to forward requests that should have gone to the web server over to the CacheFlow. They mentioned just doing that on your router or switch. That's not something a lot of switches can do as far as I know. So that stack in there is going to get another item on it. We're going to throw this PIX firewall unit. In fact, that's appropriate since we were trying to steal RAM from it. It's got two interfaces on the back. Basically, I'll be able to configure it so that traffic going to one IP is forwarded to the CacheFlow, I think. And then what I think the CacheFlow does is decide if it has the content locally that's being requested, and if not, it in turn goes and talks to the server. So yeah, this is going to be a little more involved. I hope I'm explaining this well. I'm going to go try to make it all work and make sure I can actually hit the cache, and I'll be back.
I don't have the PIC set up yet, but I've made some progress. I can see the cache working. This is my website, by the way, that we're going to test with. Mark and Ben at the Serial Port made this for me for their VCF East exhibit, and we're going to test with it. It's a pretty nice, website. We got my cat all over it. Very nice. What I'm pointing you at on the screen here is the Apache server logs on the Compaq machine, and if I refresh this, you can see they're scrolling, and that thing is being hit. Now, another way to use this cache is you actually set it up as a proxy. So I go to my LAN settings. I'm going to say use the CacheFlow as a proxy for everything on port 80. Pushed the content down there to make it a little more obvious. I'm refreshing this. There are no Apache server logs being produced, meaning the CacheFlow is serving this stuff. So it's working. This is pretty cool. This isn't ideally how I'd like to test it. I'd really like to get that transparent thing working where anyone on the network just uses the cache. We're going to try that when I wake up tomorrow. It's the next day. I've got my coffee. Let's cache some stuff.
Here's the deal. I probably could use something like the Cisco Pix to do some natting, network address translation, to forward all the HTTP port 80 traffic in the network over to the CacheFlow. The CacheFlow then in turn needs to talk to that server, and it's a little bit of a complicated network, at least for my small brain. With some of this other Cisco gear I've got, I could probably also use something called PBR, or policy-based routing. Let me tell you, there's better PBRs in this world. But this video is all over the place already. It's going to take me a long time to tinker with that. I'm sure it's easy to folks that already know how to do it, but I'm not one of those people. So to that end, Apache Bench has a -X flag, which lets you guessed it, point it at a proxy. So this thing's going to be able to pound the cache or hit the web server during our load tests. Let's get to it.
As with every next step in this video, there have been some developments. So I had to factory reset the cache. I could not get it to work. Curl allows you to hit an endpoint and proxy. So here I'm hitting my web server, 03, but I'm telling it -X proxy through the cache. And you can see I'm getting the HTML back and the logs are not being hit on the server. The cache is working. This was just failing before. There was some hidden setting in the cache that I couldn't find. It was rejecting most requests. Fix that by a factory reset. Next change, we're not going to use Apache Bench. It just loads the HTML file, but I want a more realistic test. I want it to go load the images and the CSS and all the assets the same way as if I'm refreshing in the browser. So I switched to a tool called K6. I've got this load.js file, and it just loads all the assets from the HTML file. So for example, let's hit the web server, and you can see on the screen there, it actually loaded all the assets, the images and everything the way a user would. So let's finally perform a load test. This is 5 concurrent users for a total of 1,000 iterations against the web server. We'll see how it does. You can see the logs rolling away there. And for a total of 10,000 HTTP requests, because each HTML page is loading a bunch of other stuff, we actually ended up with 820 requests per second, which is pretty impressive. This isn't a huge website, but this is just a little Pentium 3 server dealing with 5 concurrent users. That's pretty cool. 820 is the number to beat. I've scrolled the logs up a little bit so we can see what's going on. K6 also lets you set a proxy. So we're going to say proxy through the cache. Same 5 concurrent users, 1,000 total iterations. See what we get. And it's not hitting the web server at all. I was wondering if it was going to refresh periodically. Interesting. It was slower. That's why you got to do your own research, folks. Look at that. 10,000 requests, 600 per second. It was slower than just, I wonder if we've got some like network latency or something. Let's take a look here. So show HTTP stats. It saw 11,000 connections. Let's remember that number, 11,000. Let's clear the cache entirely and perform that test again, just to see what happens. And you can see it hit the server that one initial time, and now it's cached. And it's just doing a poor job, I guess. Let's see. Interesting. 800. Much closer to the server. All right, one last test. Let's crank that away. While that test runs, it's at 20% CPU. Interesting. And then, of course, a lot more connections have been hit. That test did much better, 1,000. So you're going to have to run this, I think, a lot of times. Let's do like 10,000 against the cache. I'll be back. That test is cranking along. We got her up to 50% CPU. That's pretty good. Grinding away. Looks like the most it could handle was 1,000 requests per second. Let's do that against the server. So again, we're doing 5 concurrent users, 10,000 total requests. Now, even if the cache is slower, you're also sparing your servers. So maybe the user experience or the throughput's a little less, but your server's doing nothing while the cache is fully loaded. So that's a benefit, I suppose. Throughput-wise, just a little less, 900 per second, but it was getting bogged down. This iteration duration, the max against the server was 3.6 seconds, and the max time the cache ever took was 105 milliseconds. there's an unscientific analysis of the cache flow. It works. I think it helps. One more test.
Let's see if Hannah Montana has what it takes. Gonna kick it off against the cache. It's running.
When the cache flow is idling, it sits around 3% CPU usage. Let's see now. Nothing. I don't think this thing is susceptible to the Jolt 2 attack, which is sort of what the Network World article implied. They couldn't really get anything out of it either, could they? I guess we'll point it at the server.
In an interesting turn of events, the Jolt 2 executable has frozen this machine. Restarted the Dell laptop, and I've got top here refreshing every second on the Compaq. Let's kick off the Jolt 2 attack. And I'm seeing approximately no impact. Okay, so much for that. Well, I guess that was some sort of load test. The cache works. I'm very happy about that. The Jolt 2 was a little disappointing. I'm really glad we saw it work, sort of, against that Windows XP machine to at least see a little bit of what it was all about. Clearly, the OS on the Compaq and whatever's running on the cache flow aren't susceptible to it, which I suppose is kind of interesting to know as well. But what's next for that cache flow? Well, it would be nice to get, a real network set up with the transparent stuff so you don't have to do all that proxy funny business. But first, I need to image those disks. In fact, in the CLI, it only thinks one disk is attached, so it's possible that one of those disks is already bad. The good news is, the way it's behaving with just the one disk and only seeing one of them really means that they're probably not rated, so it should be a pretty straightforward backup operation. A bunch of folks in the Serial Port Discord, MXShift, Mark, Mr. Unix, Vivi, a bunch of others, Krebs I think, if I missed your name, I'm sorry, reached out when I asked about the best way to image that disk, and so I think I'm in good hands and we'll be able to get that done. Should I find anything interesting on it? You of course know it's going on the archive. This was a whirlwind of a video. I'm sorry if it was confusing a lot of the time, and the reason is I was confused myself. It was quite the learning experience to get all this stuff set up. As always, it's super fun to set up all this old equipment. I'm glad that Compaq is cleaned up and working. It was kind of refreshing to, go through a fresh install of Linux on a server. I haven't done that forever, so that was pretty fun. If you made it this far, thank you so much. And if you haven't subscribed, please consider doing so. If you'd really like to support the channel, I'm on Patreon. I try to post early video releases, behind the scenes, unboxing, what I'm working on, that sort of thing. Thanks for following along this cache and enterprise networking hardware adventure. I hope I see you in the next one.